In this video, we're going to learn to find the prime factorization of a number. So the prime factorization of a number is a number written as a product of only prime factors. Okay, so unless the number is prime itself, there will be more than one prime factor that we'll write the number as. And here's a fact to know. The prime factorization of a number is unique. Okay, meaning there is exactly one way to write any given number as a product of only prime numbers. We could write the numbers in different orders, but there's only one way to do it. So for example, 6's prime factorization is 2 times 3. It does not have any other prime factorization. Yes, we could write 3 times 2, but these are really equivalent. Okay. So to find the prime factorization of a number, we're going to use the following method. We'll use factor trees to find the prime factorization. This is going to involve repeatedly dividing the given number by known factors and writing the results as products until we are left with only prime numbers. Okay, so we're going to look at this in this example right now, and I think it will make more sense. It's hard to describe the process in words. It almost makes it worse, so it's better just to look at an example. Okay. So find the prime factorizations for the given numbers using factor trees. Write the final result in exponential and factor form. So we'll see what that means. Okay. Now, a good way to start, since we know a number that's divisible by 2 or has 2 as a factor ends in 0, 2, 4, 6, or 8, or a number that's divisible by 5 ends in 0 or 5, a good way to start is to see if the number ends in either of those, and then that could be your first factor pair. Okay, and you can actually use any factor pair you want to start with. So 12, well, it's 6 times 2. I know it's even, it's divisible by 2, but it doesn't matter what you start with. I'm going to start with 3 times 4. In the end, you'll still get that one prime factorizations. Okay, so 12 is equal to 3 times 4. 3 times 4 equals 12. Now, 3 is a prime number, so let's look at our list of our first few prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, and again, they go on forever. Okay. Once you get a prime number, I want you to circle it because that's going to be part of your prime factorization. So you want to circle it so you remember to include it, and you also can't factor it any further. Okay. Now 4 is not prime. It's equal to 2 times 2. So we're going to factor 4 further, and 2 is a prime number, so I'm going to circle both of these 2's. Okay. So now in the factor form, okay, it's 2 factors of 2 and a factor of 3, but you want to write the factors in increasing order. It helps us to keep track of the factors, and it's also how you're going to need to enter them in Math AS. So we have 2 times 2 times 3. This is the factored prime factorization of 12. And in exponential form, if we have any repeated factors, we want to write them as an exponent. So this is 2 factors of 2, which we can write as 2 squared. And there's only one factor of 3. We could write it as 3 to the first power, but we don't because it's implied when there's no exponent that it's to the first power. Let's look at the next one. So we have 75. Okay, and you may be able to think of factors of 75. It's 3 times 25. But if you're not sure where to start, it ends in a 5, so we know it's divisible by 5. So I'm going to put a 5 here. And the question you might be wondering is, well, what goes here? Well, we learned to find the other factor. We can use our calculator, divide 75 by 5, and we'll get a whole number result since 5 is a factor, and we get 15. I'm going to put 15 here. Okay. Now 5 is prime, so I'm going to circle it. I don't need to factor this anymore. 15 is not prime. It has factors besides 1 in itself. Notice it's not in this list. It ends in 5, and it actually equals 3 times 5. Both 3 and 5 are prime, so I'm going to circle them. Okay. And the product of these factors is my prime factorization. So in factored form, I'm going to put the smallest number first, which is 3. 3 times 5 times 5. You need to include both factors of 5. Okay, you're not listing them. Notice this product, let's show this. If I multiply 3 times 5 times 5, I get 75. This product equals our number. In exponential form, there's one factor of 3, so I'm just going to write that as 3, and 2 factors of 5, which is 5 squared. Okay. Now, our next number is 155. Okay. Again, I'm noticing it ends in a 5, so I know it's divisible by 5. You can always look for even numbers and 5s if you can't think of any factors off the top of your head. And let's see. 5 times what gives us 155, and we get 31. So we have 5 times 31. Okay, 5 is prime. 31 is actually prime also. This isn't in our list here, and maybe you're not sure if 31 is prime or not. Okay, so let's think of how we can check this. Okay, well, it's less than 121, so we only have to check, is 31 prime? Because we want to know, can we factor this further? Well, it's not divisible by 2 because it doesn't end in 0, 2, 4, 6, 8. It's not divisible by 5 because it doesn't end in 0 or 5. So we really just need to check if it's divisible by 3 and 7, which we can do on the calculator. And you might know this from your multiplication facts. So if I divide 31 by 3, I will get 10, remainder 1, which looks like that as a decimal. And if I divide 31 by 7, well, I know 7 times 4 is 28, so it's a little bit bigger than 4, but not a whole number. Okay, so now I know that this number is definitely prime. So my factored form is just 5 times 31. And sometimes your exponential form is the same as your factored form. Okay, so since we didn't have any repeated factors, we would write this exactly the same.